Hello everyone. Today we are going to see a very important problem. That problem is based on function. So first let's see the question. The question is, if you see there is a function given and that function is a defined function. And we have to prove that this function is nothing but odd as well as even function. So if we go to the definition of odd and even function. So if y is equal to f of x is a function given, and I want to know that if this function is odd function. So what should be the condition? The condition should be f of minus x must be equal to minus of f of x. If a function is even function, then the condition should be f of minus x should be equal to f of x. But what I want my function to be both odd as well as even. Means my function should satisfy the condition of this even function and the condition of odd function. And such function, there is only one such function which will satisfy both the condition, which is nothing but f of x is equal to 0. So wherever you have been told to find the function, prove that the function is odd and even, that means you have to prove that this f of x is always 0. So let's see what is f of x given. F of x is given e to the power minus of mod of ln fractional part of x, as it is mentioned, minus fractional part of x square root of, so can I write like this? If you see the question, we can write like this also, mod of fractional part of x. And second is this. Domain is not defined. For which x value this condition is there, and for which x value this is given. That we have to find. According to the question, it is given this function definition will be this, wherever it is exists. Now, first of all, if I see, I have to prove that this function is both even and odd. And if any function is both at the same time, this is only true when f of x is nothing but equal to 0. Everywhere, for every value of x, f of x must be equal to 0. But here if you see, f of x has definition given. And if f of x is both even and odd, means this should also be equal to 0. And this value for every value of x should also be equal to 0. Means I have to prove f of x will always be equal to 0 for this x and 0 for this x. So all over in its domain, it will always be 0. Now to prove both should be equal to 0, first define the domain. So it is given, first this is domain of this is nothing but wherever it is going to exist. So now if I'm going to find the domain of this, so let's find. I'm assuming you guys are well aware how to find the domain. So now if I notice here, fractional part of x is present, and fractional part of x is nothing but it goes from 0 to 1. When will fractional part x will be 0? Fractional part of x will be 0 for all integral values. And fractional part of x value will be from 0 to 1 for non-integral values. That is what we know. Now if I have to find the domain of this, now if you see it, this is the exponential function, domain will be real number. So the domain of the whole function will be transferred to the square root. This is 1 by this. Now I know one thing, if any function is under square root, so when it is going to define, when f of x must be equal to greater than 0. And if the same function is in the denominator, so when it is going to define, f of x must be greater than 0. So now if I see here if I'm going to assume this is f of x, so this is written 1 by square root of f of x. So can I say to find the domain, this value means mod of ln of fractional part of x must be greater than 0. Yes or no? It is greater than 0. And one more thing, if I notice, with ln, fractional part of x is present in the argument. So that should also be, fractional part of x should also be what? It should be greater than 0. Yes or no? Means I can see one thing, fractional part of x cannot be equal to 0 because log cannot take, the argument of log cannot be 0, it should be greater than 0. So from here I can say, from this condition I can say fractional part of x cannot be 0 means when is fractional part of x is 0? When x is integer. So when will fractional part is not 0? When x does not belongs to integer. And since fractional part of x cannot be equal to 1, so if you now notice whether this value will be always negative inside, and modulus of negative is always positive, means this is always defined, this is always true. So what is the condition? The condition is fraction x should not be equal to integers. So here what is the domain of this? Domain of this is x should not belongs to integer. Means at integer this is not defined. Why? Because at integer fractional part of x will be 0, ln will take 0 and ln cannot take 0. So this function is not defined for integers. Means this function is now defined for integer. So can I say I have found the domain? So domain is found, but my entire aim to prove the function is both odd or even. Means I have to prove this value is always 0. So now let's write it again. So this is given e to the power minus mod of ln x, sorry, fractional part of x minus fractional part of x 1 by square root of mod of ln of fractional part of x. And this will come when x does not belongs to integer, and fractional part of x when x belongs to integer. I hope till here this is clear. Now we know that when x is, so now my aim is to prove both odd and even, and both odd and even means f of x should always be equal to 0. Now let's try to figure it out whether both value for the given domain will be 0 or not. Sorry, where it went. Now if I see, when I'm giving the integral value, what is the fractional part of x when x is integer? It is 0. So can I say this becomes 0 already? Now I have to prove this should also be 0. So let's find out whether this is 0 or not. So e mod of ln of fractional part of x minus fractional part of x 1 by square root of mod of ln fractional part of x. I have to find when x is not belongs to integer, then this value should also be equal to 0. Then only I can say this is odd as well as even. Now I know that this is exponential function and we can subtract exponential function when base is same. So here base is e. I need to know, I need to write the base e here. So for that, what property we can use? We have to use the property of log. We know that a to the power b can be written as what? E log of e a to the power b, means e ln a to the power b, means this can also be e b ln a according to the property, because I want, my requirement here is e. So can I say according to this property I can write e mod of ln x, and this can be written as e ln of fractional part of x to the power 1 by mod of fractional part of x, which will be under the square root. Now according to this property b will go there. So now this will become e to the power minus mod ln of fractional part of x, and this will become, now this will go here, not here, sorry, here. So 1 by e to the power 1 by square root of ln of fractional part of x, into ln of fractional part of x. My aim is to make this value equal to 0. Now first thing we are able to do it like e and e become same. Now this should also be equal to same. But how this is going to be, the power is going to be also same. So there also there is one very important property, which is we know that mod x can be written as x when the input is greater than equal to 0, but it can be written as minus x when x is less than 0. So can I say I can also think in the reverse way? Means x can be written as mod x when x is greater than 0, and x can be written as minus of mod x when x is less than 0. I hope it is clear. One more thing. So what is ln of, see here everything is ln is given under the mod. So I want to write this under the mod. How to write this is under the mod. Now it depends the value of ln of fractional part of x. Now whether this value is positive or negative. So we know one more property. I'll give you some idea. 4, 3. This value is positive or negative, or let's say this log of 2, 0.2, 0.1. Or I'm giving the third example, log 1, this is 0.1. Or I'm giving the fourth example, log, this is 0. Let's say 2 and this is 10. Now whether this value is positive or negative, so this value will be positive. What about this? This value should also be positive. How? So remember one thing, when both argument and base are either at the same time greater than 1. See here 4 is greater than 1, 3 is greater than 1. So it will be positive. Or both at the same time less than 1 but greater than 0. Then it should always be positive. But if any one is greater than 1 and other is less than 1, so the value will be negative. So this value will be negative. Here also you'll see this is less than 1 and this is greater than 1. So this value should also be negative. This is the way to recognize whether the log is positive or negative. Now if I see ln of fractional part of a is nothing, log of base e, fractional part of x. Fractional part of x is always less than 1 and e value is almost 2.7. So can I say 1 is greater than 1, 1 is less than 1. So this value is negative. And if anything is negative, so how to write into modulus form? So this will go with minus. I hope this is clear. So can I say this I can write at e to the power minus ln fractional part of x minus e to the power, now I am writing this can be written as mod ln fractional part of x square root of part of x. Is that clear? I think it is clear. Now one more property. What is the square root of x mod x square? It will be mod x. So mod x can also be written as square root of x square. So can I say now this can be written as e mod of ln fractional part of x minus e. Now this can be written as ln fractional part of x whole square divided by mod of ln fractional part of x. Now this can be written as e mod of ln fractional part of x minus, since the both have square root, so this will go under the square root, and 1 ln x will get cancelled. So can I directly write like this, and this will under the square. Now if I see both are the same, so can I say this value will be equal to 0. So this value is also equal to 0. So can I say this value after solving also equal to 0. And since this value is equal to 0, so what is the conclusion? So conclusion that f of x will be 0 when x is not equal to integers, and it will be 0 when x is integer. Means f of x is always 0. And can you say since f of x is always 0, so this is the only function I can say that this is both even as well as odd. So from here can I say since f of x is 0, so now hence proof that we can say that this function is both even and odd function. I hope this is clear. Thank you everyone.